Hello, everybody. We left off at, let's see, I solved problem number 15 for you guys. And for problem number 15, this is problem number 15. And I think that R squared came out to be problem number 15, chapter 14. So R squared came out to be 0.84. I did, when I finished the lecture, I did exactly 8.45, and then 0.9192. So this is problem number 15. The next item that I want to talk to you guys about is, let's see, it is testing for significance. Now, what is the testing for significance? First of all, level of significance is the value of the alpha, if you guys remember. Significance test is when we test the p-value or the z-value against the given value of alpha or against the z of the given value of alpha from chapter 9, p-value and critical value approach, to see if we can accept or reject the null hypothesis. You might want to say, wait a minute, isn't this chapter 14, what does it have to do with chapter 9 hypothesis testing? As a matter of fact, in chapter 14, we are testing for the slope. Our hypothesis testing is basically testing for the slope because the null hypothesis, which is a tentative hypothesis, always assumes that beta 1 is equal to 0. We have to prove, if there is any relationship between the two, you have to prove that beta 1 is not equal to 0. Okay? So beta 1 is equal to 0. That's the null hypothesis. We have to assume otherwise. If there is any relationship between the two, then we're going to prove that beta 1 is not equal to 0. So in order to run the t-test, in order to run the test, the significance test for the beta 1, there is a test called, there are two tests. One is t-test, the other one is called f-test. We're not going to cover f-test, we're going to cover t-test. The t-test has some formulas, which is already on that sheet that I have uploaded on Beachboard on their content. And for those of you at Pomona, it's under course information on Blackboard, right? So these are the formulas for the t-test. S squared, which is actually mean square error, is equal to the square error of the mean is equal to SSE divided by n minus 2. That means if we have to go to the T table, in this case, we use the T degree freedom table. If you have to go to T table, we use n minus 2 when we're looking for degrees of freedom. All right? And then the SSE, we already have it. Least squared method, those of you remember least squared method. SSE is equal to sigma of yi minus y hat square and that is also equal to, I continue here, sigma of yi minus b0 minus b1x squared. We're not going to use this formula that much, okay? I'm just going to stick with these. And then in order to find s, which is a square root of s squared, so this, we'll go ahead and continue on with those formulas. Then we have standard error of the estimate and that is S that's square root of MSE. MSE, or you can say S is equal to, or S is equal to square root of SSE divided by n minus 2. And then, where do we get S from? Or what do you use this? I'm sorry, what do you use the S? SB1, in this case, SB1 is a standard deviation of, this is standard deviation of B1 is equal to S divided by, this is S, this S right there, divided by square root of sigma of xi minus x bar square. Xi minus x bar square. As I remember, xi minus sigma of xi minus x bar square is the denominator of the formula that we calculate B1. And then T is equal to B1 divided by SB1. So when we are going to do the t-test, we have to find the t that we calculate, compare it against t of the given alpha. T that we calc comes from B1 divided by SP1. B1 comes from the line equation regression that we developed. SP1 is this, equal to this. For S, that is the square root of SSC divided by n minus 2. And S squared is equal to SSC divided by n minus 2. Now, in a case like this, we're going to go ahead and do a significance test. There is an example on slide number 28. This refers to the previous example that they are using those values from previous example on the slide, on the PowerPoint slide. But we're going to use half of the problem in the book. Why half? Because we do only t-test. This problem has a t and f test, so we're not going to cover f-test. And when we are going to accept or reject the hypotheses, everything stays the same. So reject H0 if p-value is less than or equal to alpha. I'm going to continue up here. So this is p-value approach. If you want to use the critical value approach, critical value approach, we do t calc greater than or equal to t of the given alpha. For beta 1 equal, not equal, we do t calc greater than or equal to t sub alpha over 2. And for negative, t calc less than or equal to negative t of the alpha over 2. And these are on slide number 29. There is an example on slide number 29. Let's see. Testing for significance, t-test for that, auto new cars example from the beginning of this PowerPoint slide, slide number 30. So the H0 states that beta 1 is equal to 0. HA states that beta 1 is not equal to 0. The level of significance is 0.05. Step number 3, select a test statistic. T is equal to B1 divided by SP1. And then step number 4, decide whether to accept or reject the null hypotheses. They calculate the t-value coming out to be 4.63 and provides the area of 0.01 in the upper tail. And then the p-value is 0.05. So 0.01 comparing against 0.05, it's less than the value of alpha, then we have to go ahead and reject the H0. If you want to go critical value, so you have calculated T, which is equal to 4.63. This is slide number 31, chapter 14. And then the T of the given alpha is 3.182. T of the given alpha, you have to use n minus 2. T of the given alpha is 3.182. Then the T you calculated 4.63 is greater than T of the given alpha, therefore you reject the H0. Now, there is another method which we're not going to use, that is confidence interval for beta 1, plus or minus, this is on slide number 32. So beta 1 plus or minus for B1 plus or minus T sub alpha over 2 times SB1. So this is going to be your margin of error. You add this margin of error and subtract it to and from beta 1 or B1. And if the value that you're looking for is within that range, within this range, then you accept the null hypothesis. Otherwise, we're not going to use this method. You don't have to worry about this. And we are going to, on slide number 33, they are showing you the use of the confidence interval for beta 1, 1.5 to 8.44. And so in this range, we don't have 0 included. If 0 was included, if it was anywhere like from, let's say, 0 to this point or negative 1 to positive 8.44, then we would have accepted the null hypothesis. But in this case, we can go ahead and reject the null hypothesis. All right, we're going to go ahead and do problem number 23. Problem number 23, and this is going to be the end of chapter 14 that we want to cover. Can you turn the light for me, please? Thank you. Oh, wait. Okay. Thanks. All right. So problem number 23 is also based on the data from problem number 1. What do I mean by that? This is chapter 14, problem number 23, X, Y, 1, 2, 3, 4, 5, and 3, 7, 5, 11, 14. 3, 7, 5, 11, and 14. Part A, compute the mean square error using equation 14.15. Equation 14.15 is this, part A. S squared is equal to SSE divided by n minus 2. So when we solved for SSE, SST, and SSR in problem number 15, if you go back to problem number 15, because that was also based on the data from problem number 1, SSE came out to be 12.4. So SSE is 12.4. And then we have 1, 2, 3, 4, 5 data n minus 2. So that's going to be 5 minus 2. So S squared is going to be equal to 2.033. I'm sorry. That was the answer to part B. 4.133. For part B, compute the standard error of the estimate using the equation 14.16. Equation 14.16 is this one. S is equal to a square root of SSE divided by, this is standard error of the estimate, divided by n minus 2. So that's a square root of 4.133. And then S is equal to 2.033. For part C, compute the estimated standard deviation of B1. So let's estimate the standard deviation of B1. So I'm going to go ahead and erase this. 214, problem 23. So for part C, SB1 is equal to S divided by square root of sigma of xi minus x bar squared. Okay? So we have S. We need to know what xi minus x bar squared is. I don't know how many of you guys remember that x. Let me just refresh you guys' memories. Let me erase these. If you guys remember, S, back in problem number 1, so B1 was what? 2.6. 2.6. And this is how we found that B1. B1 was 26 divided by 10. 10 is the value for the sigma of xi minus x bar squared. This is from problem number 1. So that value is xi minus x bar squared. Sigma of that is 10. So we have S, which is equal to 2.033, and sigma of xi minus x bar squared is equal to 10. And then SB1 is equal to 2.033 divided by 10, square root of 10, square root of 10, and the answer is 0.643. SB1 is equal to 0.643. For part D, use the t-test to test the following hypotheses. This is the following hypotheses. H0, this is part D. H0 states that beta 1 is equal to 0. HA states that beta 1 is not equal to 0, with alpha equal to 0.05. With alpha equal to 0.05. Okay? This is for part D. So we go ahead and start with the T formula. Part D continues over here. T is equal to B1 divided by SB1. So B1 was what? 2.6. This is coming from problem number 1. Divided by SB1, which is 0.643. This is SB1. Again, refreshing you guys' memories about that 2.6. Y hat is equal to 0.9, I think, plus 2.6. Was it 0.9? Oh, 0.2, sorry, 0.2. This is what it was, 0.2 plus 2.6x. This is what we developed back in problem number 1. So 2.6, that's our B1. All right? And then T comes out to be 4.04. 4.04. 4.04. This is the T that we have calculated. Okay, they ask us use the t-test, and what is your conclusion? Using the t-test, we have to go and find out what the t of the given alpha is. Okay, or we can go and find out about the p-value. Let's see. The t we had degree of freedom. So we have n is equal to 5 minus 3, okay? Or, so the t of the given alpha, go under the column, go to t distribution table. T distribution table for 11th edition users is on page 980. For 12th edition, it is on page 976. For 13th edition, it is on page 978. Some of you guys will send me an email like about, let's say 2, 3, 4, 5 days from now and ask me, what are these page numbers? What is the page number for the T distribution table for Z and so on and so forth? I don't remember. I do remember some numbers, but I don't remember all these page numbers to answer you back right away. And I always guide you or ask you to go to the Appendix B. These are all in the Appendix B of your textbook. So anyways, 3, we have the sample size is 5, minus 2, that is equal to 3. And then go across, locate number 3, degree of freedom. Go across number 3, and then under the column 0.05, the T of the given alpha is 2.353. 2.353. So this is T cap, and T of the alpha is equal to 2. Wait a minute, sorry, this is equal, not equal. This is equal, not equal. We have to go under half of the alpha. Alpha is 0.05, half of it is 0.025. So under the column 0.025, That is 3.182. So T of the alpha is equal to 3.182. This is for, because this is equal, not equal. Okay? So if I want to write down those values, the degree of freedom, 1, 2, and 3. And then we have the boldface, we have 0.2, 0.1, 0.05, 0.025. This is part of the degree of freedom table. Okay? 0.05, 0.025. I have to bring this in here that you guys can see. Okay. 0.2, 0.1, 0.05, 0.025. And then across from here, under the column 0.025, it is 3.182. Okay? So this, comparing to this, we said we reject the H0 if the T that we calculated for a positive value is greater than or equal to 3.182. In this case, it is not greater than. Then we do not, wait a minute, 0.0, hold on. We said reject the H0 if our T is greater than this. Now our T, which is 4.04, our T value is greater than 3.182, then reject the H0. So one more time, I get confused over this. Here, reject if T calc is greater than or equal to T of the half of the alpha. So in this case, our T is 4.04, which is greater than T of the alpha, then we reject. If you want to go by p-value, the p-value, so alpha is half of the alpha is 0.025. Okay, if you want to go ahead and find what the p-value is, we go ahead and try to locate 4.04. So for 4.04, let's see, across from 3, 4.04, no, it is greater than 0.025. So 4.04 is more to this side. So this is, so 4.04 is more to this side. And then the value of the P is going to be less than this. Okay? So the value of the P is going to be somewhere in that area, and that is going to be, let's see, 4.04. The P value is going to be go ahead, it's going to be anywhere between 0.0, less than 0.025 and less than 0.01. Because if you go to the table across from number 3, the next value is 4.5. Our value is 4.04. So even if it was equal to 0.025, we still have to reject, because we say we reject H0 if p-value is less than or equal to alpha. So it's less than that, less than 0.025. So therefore, we have to go and reject the H0. That means there is a slope and there is a relationship. And we calculated the value of the B1, and again, the B1 came out to be 2.6. B1 was 2.6. That's why you have to reject the H0. It says beta 1 is equal to 0. So this is the end of chapter 14. And there is one more item that I would like to cover for you. This is out of chapter 12. This is called chi-square goodness of fit. So chapter 12, chi-square goodness of fit. Chi-square is shown by this symbol. Let's see what chi-square goodness of fit is. At times when we are dealing with some researchers that are conducting their research in the areas using more than one factor. When there is a research done by considering more than one factor, then you would like to see if the result of this research that is using more than one factor is also true in the area that you're living in or in the field that you're working at. You're working at this field and you want to find out if the result of this research, statistical research, if that can be applied, and that is going to be true in the field of your work or the area that you live in. I'll give you an example. Let's say that the state of California publishes the research results stating that the